Good morning, mathematicians. How's it going? I guess I should always wait to make announcements until, people file in. Good morning, mathematicians. Hope everyone's doing well on this Saturday, assuming it is Saturday, wherever you are. I was looking at possibly discussing the evaluative criterion today, but I don't know if I want to do that much reading on stream. Hello, Seek. Hello, Matthias. How's it going? Maybe we'll just ease into things with checking to see if anything's new on archive. And then I'll yap about random things. Oh. I don't think I've seen this yet. Or, wait, have I seen this? I don't know if I've seen that one either. No, someone did mention that one on stream, actually. We introduce limit categories for... How do I read? One word at a time, Boris. One word at a time. Hello, MD Explains. Well, I'm glad you're back. Perhaps the whole point of office hours is for everyone to be less of an idiot, myself included. You must have spent an entire semester on Quillen's paper when you were doing your master's thesis. Yeah, well, Quillen has some crazy stuff, so... in mathematics, is learning theorem like just memorizing them first and going to the understanding part? Will this method work? Well, I don't want to say that some such method works or some such method doesn't. You got to do what works for you. But, probably you best learn a theorem through doing exercises which have you apply that theorem. You probably end up, as you write out the proofs in full detail, will end up accidentally memorizing that theorem on the way as you apply it properly. Can I intuitively explain why two events being disjunct and independent are very different? Why two events being disjunct? Well, what's the definition? Disjunct events. It just means the intersection of the set is empty? Okay. And let's see independent events. Right, so that's right. That's an extremely that's a very different thing. Right, can I explain intuitively why two events being disjunct and independent are very different? Well, I mean, it is like disjunct, it seems, would be something like if we had I don't know, you're looking at like say you roll two die, right? So A is the outcome of the first die and B is the outcome of the second die. These are actually, is this a good way to phrase it? Then the probability of the intersection doesn't make sense. Yeah, I mean for like disjunct, like you can't roll a 1 and a 2 and then simultaneously roll a 3 and a 4, right? Like these are just totally, these are like separate possibilities, right? So these are disjunct. But you could roll, um, your first roll could be a 1, and the second one a 2, and your first roll could be 1, and the second one a 3. So, I don't know if this is a good explanation of it, actually. The proof of Sayre's conjecture compared to Susslin's proof is very different flavor. Your enemy has the best exposition of Quill and Susslin, unfortunately. Wow, that's big of you to admit these things of your enemy. Landau and Lifshitz is the Bourbaki of physics. Is that true? Why would you say that? I'm genuinely asking. I don't know. Did they write a whole bunch of physics like textbooks and have a certain philosophy in mind? Like, in what ways do you think they're similar to Bourbaki? Disjunct equals hate each other, independents literally don't care about each other. Yeah, that's a good way to say it. Yeah. Okay. What, oh, I want to go back and just see this beginning of this paper. We introduce limit categories, classical limits of categories of D modules, develop their general theory. Okay, that seems cool. Then something about geometric Langlands. I was trying to understand the stack of unipotent Langlands parameters yesterday. Yeah. Oh, I should plug in my laptop. I wonder, I should be looking if there's any, like, learning seminar. I really want to understand Ben's V's paper between the coherent and constructible Langlands, and use that to connect more aspects of my research group's work to the modern perspective. But where does one start? Where does one even start? I ended up going back to the Bungee seminar. And you can see here I was scrolling through these documents, trying to make sense of such things. Yeah. Good night from Singapore. Good night. I hope this has been calming bedtime meditations for you. Okay, I should probably yap about some random stuff. The question is what? I wonder how much I can remember of the process by which one builds representations of semi-direct products from Sayre. Because a week or two ago I was reading about this, and I thought it was really fun. Yeah. So I think part of it was that if you have a semi-direct product of G by an abelian group, 10:20 p.m. there apparently. Time to get to bed, nerdy Quigsire. 6 hours to go. 6 hours to go till bedtime? You go to bed at 4 a.m., Boris? Reading is so gross. Well, good luck in the fall semester, nerdy Quigsire. That's all I can say. Oh, you learned all your math from YouTube and Reddit. Well, there's actually, I don't know how true this is, but there's this one person in this Discord server I'm in, and she just seems to have the answer to everything all the time. And then people have asked, like, oh, how did you learn this stuff? And they're just like, from the internet, LOL. And I'm like, damn, crazy. What a hero. Semi-direct products should have a universal property, sort of. Is that true? Well, I would be skeptical of the math you learned from 4chan. Except actually, there was that paper on super permutations. There was a paper on super permutations that came out of 4chan, actually. So, yeah. Yeah, actually, I guess hanging out on 4chan could lead to research experience. Learning math from YouTube and Reddit is diabolical. Yeah. And lab gremlins mustn't be trusted. Though this is bold words. This is bold words. I should know, for you are one of them. I see. Oh, we got insider information. Yeah, does the... Okay, I was going to talk about representations, and I will in a second, but does the semi-direct product have a universal property? Given two groups... What about... Oh, maybe there's a related math overflow thing here. And maybe they linked the same post, I don't know. Well, you're reading the important stuff, nerdy Quigsire. The universal property is just the explicit presentation? I don't know about that. How is that a universal property? First, note that the group can be considered a relatively simple category, sure. If we assume that our semi-direct factors are encoded in this way, then one can encode theta. I guess that's the, action. Yeah. From K into categories, one obtains as a growth and deconstruction / con extension. Interesting. Huh. Interesting. As a lax 2 colimit. Huh. Mapping out of a semi-direct product is the same as mapping out of each factor. And ensuring their images satisfy the defining conjugation relations. Right. Yeah. But one of the maps is not a group homomorphism. Out of one of the factors? I mean, the 1 out of Q should be, right? Because that's like a quotient. Or am I wrong? Both these options are on. Huh. That is interesting. Yeah, what are these other posts? Oh, speaking of Bourbaki. It's a universal property here. So for N and H is the quotient group, I guess. So for any maps out of the individual things, let these be two homomorphisms into a group G such that this condition is satisfied for all elements. Then there is a unique morphism extending F and G in the usual sense. Nice. Okay, cool. I guess I should put, maybe I should put that in a future video. The notation doing a lot of heavy carrying in the cool department. Yeah. I never really, I don't know, we never talked about semi-direct products much in my undergrad. I only, really got my hands dirty with them in more recent years. When I taught Algebra 2, we actually didn't end up covering semi-direct products there, but I was, still taught myself about them properly. Semi-direct products like fiber bundles. G to BH defines an H bundle over G, and then G into aught H defines a split extension. Interesting. Actually, maybe I can dive into a little bit of near quackery. You hear horror stories from that algebra class, by the way? Yeah, from who? From who? From which people? I'll have you know that the grade distribution of that Algebra 2 class was curved to meet the grade distribution of other years. And having taught and attended multiple universities, I think it was a pretty normal Algebra 2 course. Of course, students who maybe didn't do so well are going to disagree. But how many Algebra 2 courses have they participated in? Oh, I don't want you to snitch. I don't want to know who. But I guess I did say who. I meant that more as think about. I don't have a rate. I don't think I have a rate my prof. I've looked before. Rate my prof. Yeah, there's no rate my prof for me. Yeah. If TAs get it, no, they don't. But reacting to my reviews would be a vid. Yeah, in the future, definitely. In the future, that'll definitely be some content. On exchange in Europe right now and taking a measure and integration course. It's an undergrad course, and you feel so far behind already. How would you fill spare time when you're way ahead? Hang on, I don't quite understand the question. So you're behind, but you want to know how to fill time when you're ahead? Sorry, you feel so far ahead already. I misread that. Interesting. Yeah. I would, I know for me, it's an issue if a course feels too easy for me, then I paradoxically do very bad on it because I start to think that it's beneath me, and I feel like I don't have to study or work on it, and I get very bored and uninterested, and the homework becomes like a pain because I'm like, oh, I did this already, and then I tend to do worse on a course that I should by all rights get an A+ on. So I would say definitely, if you're anything like me, make yourself stay humble and make sure to do your homework. Yeah, what to do if you're so far ahead? I mean, then just use that time for anything else. So I would still make sure, yeah, okay, if you're in the same boat, then yeah, or in the same way, then yeah, I mean, just be careful. Try to still, try to still take the course seriously. Use that time for literally anything else that you want to do. You know, if you do want to keep it related to the course, then you could read ahead to further chapters. I also think I think it's good to always make use of office hours as well. So, if you truly are, if you're ahead, you want to read about more advanced topics, go bug the prof in office hours and ask them questions about more advanced things. Yeah, I don't know. That would be my advice, I suppose. But yeah, I don't know. It's hard. They can rate you in the comment section. That's true. That's true. Yeah, big DJ Khaled moment. If you're enjoying the course, you can try writing down detailed notes for it. Yeah. And ideally reference a prof who taught it. Yeah, that's a nice idea. Yeah, if you're really on top of it, make a nice set of notes. Share those notes with the other students in the class. They'll probably enjoy it. They'll probably be thankful for that. Yeah. Exactly, Rad. Yeah. What was I gonna say about this? Oh yeah, I was gonna try to see if I can remember from last week. So what is it? I think that so G acts on A in this way, right? And so that also means that G acts on the set of characters, complex characters of A. Hello, Fimno. Haven't seen you for a while. How long are we doing today? I don't know. What time did I start? We're definitely maybe 15, maybe 10 more minutes. Maybe definitely done by 9 at the absolute latest. I got to keep it short because I got work to do. And I'm moving tomorrow. Oh yeah, office hours maybe not happening tomorrow. I guess it depends when I get up. I only have to pick up the truck at 9. So yeah. Whenever you're starting to feel like you could have explained it better, it's a good sign you're starting to really understand the material properly. Yeah. It's tough too since you're not a huge fan of the book the course is being taught out of. Yeah, that makes it even harder. I would try to consult another book as well as you're building your notes. Write superior notes to the book out of spite. Yeah, let that work. Let the spite, the hatred of the book, fuel you to spend your time writing notes that you feel are better than the book. That's the power move here. Streams are getting shorter every day. That's inflation, baby. That's just basic economics, or deflation. I don't know. The truth of what it is it's me needing to write my damn paper, and I don't want to abandon you guys again. So I want to keep office hours alive, but I also don't want to spend as much time on it. Good books for reference for measure theory. I don't know if I've ever found a book I'm in love with, but there is I did use Bartle, which I wasn't crazy about. It seems like weird in like all of these different orders, but it was good enough. I feel like basically using a mix of Bartle and Rudin, baby Rudin actually, to start. I also do have a book of Paul Halmosh's book on measure theory on my shelf, but I've never seriously cracked it open, and it's probably a little dated. But Halmosh is also famous for being a good expositor, so. Where am I? What am I doing? What was I gonna look up? Khan. I think I've heard of it before. Baby or Papa? Well, probably either. I think Baby Rudin has some like introductory measure theory. So I think my first measure theory course was a mix of Baby Rudin and Bartle. But probably I would imagine like Papa Rudin has a better introduction there. By Forster, if it's available in English. Yeah. Oh, you wanted to ask if I could talk about reductive groups over non-Archimedean local fields. You want to take a course on that next semester, and you don't know a whole lot about it yet. Yeah, I could say something. I could say something about it. Yeah, actually, what to say? The course is specifically on reductive groups over non-Archimedean local fields. Interesting. Yeah, what should I say about it? I mean, because I guess a lot of the things I do is I don't think so much about the actual group structure. Actually, that's maybe a lie. But there's almost not so much that, like, okay, there are special things that happen for non-Archimedean local fields, but, many of the times I'm not even thinking explicitly about those entries. So what's a quick recap of things that are important to know? Well, very importantly, I guess, is that if you've got your reductive group over one needs to be careful about like integral models and stuff, and I'm not careful about this all. The goal is to prove Bernstein decomposition as a category of all smooth representations. Well, that's very cool. You should go check out Bernstein's notes. And they're made by like Kyle Rummelhart or something. I wish that there was a nice like reviewed typo corrected version of those notes, but who's going to do that? You should go read those notes, though. Yeah, Bernstein decomposition is cool. If the course is so specific, surely there's like 5 people taking the course. That's true. Yeah. Ask the instructor. But come on, we love talking about reductive p-adic groups on this stream. Well, look at Nerdy Quagsire wheeling and dealing. Yeah, $10 for Papa Rudin, but how much for the shipping, Nerdy Quagsire? So, you guess there's a lot more. Oh, Jessica Finson is teaching it. And yeah, indeed, she is fairly famous. Indeed. Indeed. We'll definitely pay close attention and learn a lot. And work hard on that course. Yeah. I wish I had worked harder the few times I encountered courses with famous people. Yeah, don't waste the opportunity to learn a lot. You've got your LibGed copy, yeah. Yeah. I'm not sure. What should I say? What should I say about reductive groups? Just general structure, or should I say a bunch of stuff about the representation theory? I don't know. I think about the GLN case a lot. Any tips on approaching a supervisor for a master's? I don't know. I don't know if I have general advice for such a thing. Like when I approached my professor for a master's, I just, went up to him and I was like, hey, I see you have algebraic geometry in your research title. Seems interesting. Let's, yeah. Are you looking for students? That was it. Yeah. So I don't know. I'm not sure. I'm not sure what else to say there. Yeah. Probably in general, people say you should get a sense of what they work on and like try and read their abstracts, and that's true. But also, like, I think most people know, like, unless you're, really a super genius, I think most professors know that you don't actually have any idea what their work is about. So don't worry too much about that, and definitely don't try to come off as knowing something that you don't actually. Just be honest. Just be like, hey, like, I don't know what class you're in, but let's see, because Will Day just showed it representation theory. Let's say it's representation theory, right? Just as an example. Just be like, hey, look, I took a representation theory course. I really enjoyed it. Considering it for my master's, I see your research has something to do with representation theory. I'd be interested in learning more, blah, blah, blah. Are you taking on master's students? Email back being like, hey, big cheese. Yes. If it was me, that's the thing. For some professors, they would probably instantly, if you just said that, they would instantly take you. I would if I was a professor. But you don't know that ahead of time. Yeah, it is interesting that Geo is maximal compact. Not very similar to the Archimedean case, exactly. Good morning, Ken. Is the Deligne-Lusztig related to these representations? Well, it depends on what you mean by the Deligne-Lusztig. Because there definitely is, like, Deligne-Lusztig classification of representations of, affine Heck algebras, which corresponds to the principal block of the categories of representations. Yeah, take a seminar with the person you want to and advise you and ask questions. Yeah. Hey, by the way, Fimno, is this seminar Is it the course? I guess it's just an ordinary course, right? An in-person course. If it was an online course, maybe I'd sit in. I mean, I already know about the Bernstein decomposition and stuff, but doesn't hurt to sit in on such things. I wonder what sort of courses are available. I do want to see if there's like I don't know. Langland seminar, online Langland seminar going on. Actually, why am I here? Why am I not on the research seminars page? That's how you approach this prof at your uni who does research and representation theory? He hasn't responded. Do you reach out to who I think you reached out to, Nerdy Quagsire? You should definitely message me about that if you're actually interested in pursuing that. Hey big dog, where my response at? Yeah, send me a message, Nerdy Quagsire, if you're legitimately interested in such things. Deligne is speaking at Harvard this year. Nice. For the non-Archimedean case. Yeah, but I'm still not exactly sure. Like, yeah, I'm still not exactly sure. If you just mean the Deligne-Lusztig classification, normal lecture course at your uni, yeah. Oh, Ken Lola, first meetup, K theory, fans of K theory meetup. World of Groupcraft. What is interesting. Am I looking for geometric Langlands or arithmetic Langlands? For geo, there's that workshop now. There's a workshop now? Where? You're a math student starting a course on measure theory. Hey, we were just talking about measure theory earlier. Do I have any recommendations? Yeah, we were just discussing possible recommendations earlier. I started with the measure theory that appears in Baby Rudin, a combination of that and the book by Bartle. It was fine. Wasn't a mind-blowing reading experience, but it was fine enough. Well, the Deligne-Lusztig classification, that is not too hard to say, because that's basically my research. That's basically my research. I mean, the principal block of the category, so just a certain special subcategory, maybe I'll just write it with a little dot, of representations is equivalent to modules over an appropriate affine Hecke algebra. And the modules over the appropriate affine Hecke algebra are basically labeled by a choice of a semi-simple element in the dual group and a nilpotent a choice of nilpotent where conjugation, which is in the Q eigenspace of conjugation by S, Q is the residue degree of the extension of QP. And then one last thing is that you have the so the stabilizer of, okay, so I should say, let's say the collection of all such for a fixed S, the collection of all such X, let's call this VS to be the collection of all such S. X for a fixed S. These are basically the Vogel varieties I talked about before. This is acted on by the centralizer of S. And then the final piece of the data is we look at the centralizer. We define the component group of at a point X, which is up to isomorphism, independent of the orbit. So you look at the double stabilizer. So basically the stabilizer of this group acting on VS modulo the connected components. And you look at the irreducible representations there. And so basically, I mean, I don't even know. Oh, top chat, right. Sorry, I noticed people got to remind me, like, at the beginning of stream to always change it from top chat to all chat. There's so many questions I'm not going to get into. I need to go right away and do my work on my work. And so anyways, finally the takeaway is that the modules, the irreducible modules, actually, there's a bit of a lie here. We overcount things. So if pi is a representation of this group, then well, I'll say it this way: the set of all triples up to equivalence, where meaning the choice of X shouldn't matter, like it doesn't matter the conjugacy class of S or the choice of X in a given orbit. This should surject onto the simple things here. Yeah, I mean, this is also basically, I mean, this is just like part of Langland's geometric Langland seminar. Wow. Yeah, maybe I should just yeah, well, okay. Well, we'll come back to this. Okay, let me just look through some of the questions. We're gonna wrap up. Still haven't decided yet, but there's a prof doing math phys and one doing rep theory, conflicted between the two because you love both. Yeah, that's a tough choice. You think the physics professor might be emeritus and not taking students anymore? Well, then your choice is made for you, I think. I would say go for the rep theory. When I become a quant, bro, I can connect to the super speed lines. Yeah. Yeah. Just stick a plug in somewhere. That is exactly how the internet works, Boris. It's because Kay is a struggling grad student and can't afford fast internet. Yeah. Could I explain Dinkin diagrams? Maybe next time. Maybe possibly not tomorrow because I'm moving. We'll see what time I get up. I hope your messages still aren't being filtered, Arad. I put it on live chat, so I don't know. You're trying to reply about geometric Langlands. Yeah, but I think sometimes it buries links if you're including links. I don't know if you included links, but you know that already, so I don't know. Can I describe any explicit example of special varieties that come in describing the representation theory? Yes. In fact, I have before. Paul Maurice. If you go look back maybe a month ago, or 2 months ago, or something, I talked about this. So with this story and these triples, I talked about the example of C star acting on C by t dot z equals t squared z, and we got these like 3 orbit pairs, and I talked about like the D modules and perverse sheaves. I mean, we can talk about it again soon in the future, but yeah. In the meantime, I do have some older office hours on that. Thanks for the clarification, Nerdy Quigsire. You've never seen a non-depressed grad student? I don't know if I'm depressed. I wouldn't say I'm depressed. Maybe stressed at the moment. I wouldn't say I'm depressed. You're learning algebraic geometry from Vakil's notes. Good move. And my videos helped, so you get started. I am glad to hear. Not a link. It was masterclass proof. Oh, right. Yes, you have mentioned these. Before I looked at the videos. I feel like I need something a little bit more for babies, though, at first, to get my head around some of it. I mean, yeah, because again, I do understand geometric Langlands in general, but I specifically I want to understand the circle action stuff from Ben's V's paper, and understand, I want to try and relate what we're doing somehow to the picture of the stack of unipotent Langlands parameters, and go through that coherent constructible correspondence there. And I don't know if there's anything that can specifically help me with that. I might just need to reach out to people in the know and ask their opinion on what I should read up. Right, I remember something about that equation. But I think that might be in a slightly... Doesn't that originally show up in, the finite case? I'm not sure. Anyways, I said I wasn't going to go later than 9, and it's 8:59 here, so I'm going to kill the stream. But we can talk more, if not tomorrow, then on Monday, about the Drinfeld case and Dinkin diagrams, definitely. Okay, I'll see y'all then. Go prove some stuff.